All right, so on number 1, what is not simplified?
I can't tell.
The screen capture.
The radicand is 56. So last class we kind of practiced doing your perfect squares. Let's just do a little factor tree here. So what times what is 56?
7 and 8.
Okay, so 7 and 8. 7 is prime, 8 is not.
4
4
2.
2 2.
Dates, staying home, staying home. So, who's going to come out front?
2.
2, but there was already a negative 2 in front. So what do we do?
Negative 4.
Yeah, we multiply. So we will get negative 4 square root of 2 things stay home. So 7 times 2 is 14. So your final answer will be negative 4 square root of 14. Yeah.
So you took the 2 white boxes and multiplied them.
If they stay home, they multiply. If
Okay.
they come out, they multiply.
Then you just doubled the outside numbers.
Well, because there was a negative 2 in front is why we
How can
doubled
you
it.
get negative 4?
Because you just doubled it.
The 2 that comes out times the negative 2 that was already out. 2 times negative 2 is
That
negative
was
4.
a different number.
Yep, so if there was a negative 3 in front, you do 2 times negative 3, we'd have a negative 6. Okay? Number 2. So last class we learned we multiply whole numbers times whole numbers and roots times roots. So what is 2 times 3? Okay, so that's 6 for sure. And then the square root of 3 times the square root of 3 is the square root of 9. That's our multiplication property. Just like 3 times 3 is 9, the square root of 3 times the square root of 3 is the square root of 9. But what is the square root of 9? 3. Yeah, so really this is 6 times 3. So we get a nice pretty answer, 18.
Thank you.
Thank you.
Thank you.
Okay, and then number 3. Let's simplify. It's usually easier to simplify first because then the numbers get smaller to begin with, as opposed to multiplying big numbers and then you have to simplify this really big number. So before I do my front times front, inside times inside, let's break down 20. 20 would be 4 and 5. 4 is 2 and 2. So 2 stays home, 2 goes to prom, 5 stays home. So I have negative 3 square root of 2 times, who goes to prom?
8.
The 2, but there was already a 4 out front. So how much is going to be in front of this one? 8 square root of
7.
5.
38.
Now we're basically back to number 2. Numbers in front times numbers in front gives me negative 24. Negative 3 times 8 is negative 24. Square root of, what is 2 times 5? 10. That is your answer. Now be careful, sometimes this can simplify again. But if I did a factor tree right now, obviously it's 2 and 5, because that's just what we got, and that doesn't break down any further. But double check, always think, can it simplify any further? Are there any more perfect squares that can break out of here?
No.
Good, and last, number 4. I'm going to do this the way that we practiced last class, okay? Not the factor tree, but the other way. Remember that one? So this is 4 square root of 2 plus 3 times, and I'm going to break this into 2 separate square roots. And when I see 50, my eyes automatically are thinking about a perfect square that divides out of 25. Yeah. So 25 times what?
2. Dose.
25 times 2. Right? Just like 2 times 25 is 50, the square root of 2 times the square root of 25 is the square root of 50. But what is the square root of 25? It's actually 5. So 3 times 5 is 15. And now what do we notice about all 3 terms? They all have the exact same square root. So this is kind of like 4x plus 15x minus 3x. Where I have 4 watermelons, and then someone gives me 15 more watermelons, and then I eat 3 of those watermelons in one sitting.
Dang,
Bet.
Mr.
I do love watermelons. So what is 4 plus 15?
19.
Minus 3.
16.
So 16 square roots of 2 is my final answer.
Can you do it the
Watermelons.
factor tree way?
It would be the same. The only difference is this step right here.
Whoa, it does get laggy.
You would just do a factor tree with 50. So you could do 25 and 2, 5 and 5. 2 stays home. So 5 comes out with 3, so you get 15. 2 stays home.
So
It's
you
the same
always
thing we
have to
got.
get the inside number the same.
Yeah, in order to add them. So for example, if this had like plus the square root of 3 out back, if the original problem had plus the square root of 3, can I add that to a square root of 2?
No.
No, that's kind of like x plus y. They're not the same, they're not
So
like
you
terms.
just like put it at the end.
Yeah, so in that case, if this was my original problem, all of this did simplify to this, but then I can't add a square root of 3 to a square root of 2, so I just do plus the square root of 3, and that would be my final answer. You just keep them separate, just like x plus y. We can't combine those, so we keep them separate. A rational number
That's
Let's go.
can be written as a fraction. Circle that. That's a big deal. You need to know that the rest of the year. A rational number can be written as a fraction. It's rational.
Circled.
So, for example, 1/2 is a rational number. 2/3 is a rational number. I would write these examples down. -1/5 is a rational number.
Dude.
What about 3? Is 3 a rational number?
No. So you recorded
yes.
3 over 1.
Yes. Whole numbers are rational numbers. 3 over 1. Okay? All of these are rational numbers. Okay? What about 0.25?
No.
Well, yes, it's 1/4.
0.25 is 1/4. So yes, 0.25 is a rational number.
So is everything
Anything that you can put into your calculator, for example, in your calculator, I'll do it on my board because I can do that now with my touchscreen. In your calculator, if you put 0.25 in the calculator, how do you turn a decimal to a fraction? Do you remember?
Up.
Math 1 is enter. Hit enter, 1/4. So yes, 0.25 is a fraction. Okay? Something that cannot, circle this, cannot be expressed as a fraction is irrational. Bad.
Oh.
Where are you? Are you okay?
So some numbers that are irrational. Anyone know? There's a one really obvious one everyone always says.
1.
1 can be written as a fraction. 1/1 is rational.
0.
Pi.
3.141.
Pi is irrational.
Oh, wait. How do you
Really?
calculate that?
The number e is irrational. If you don't know about the number e, it is right here. It's above the division sign. So second e is 2.718281828. But it goes on forever. It's repeating. See, watch what happens. Watch. Math, fraction, enter. Your calculator said no, not today. It cannot do it. Your calculator physically cannot turn it into a fraction because it's a never-ending decimal like pi, okay? Obviously your calculator cuts it off because it doesn't have a never-ending screen, but there are some other ones that are also irrational. The most commonly is the square root of a non-perfect square. So what about the square root of 4? Is the square root of 4 rational?
Yes.
Yeah, because what's the square root of 4? 2, which is 2/1. However, the square root of 5. If you put the square root of 5 in your calculator, you get this really ugly decimal. And if you ask your calculator to turn it back into a fraction, it says no, I'm not going to do that. So that's how you can tell if something's rational or irrational. Is put it in your calculator, see if the math fraction enter works. Okay? So now, let's think about our fractions. And we're going to compare it to our house.
Why don't we have a house?
The denominator of a fraction, so remember, a over b, a is the numerator, and b is the denominator.
We write this.
Sure.
I don't have a house though.
You always want, the denominator is the foundation. The denominator is the foundation of the fraction. So think about the foundation of your house. What's the foundation of your house made out of?
Concrete.
Concrete, something really solid that your entire house can sit on, okay? What do we know about a fraction if the denominator is irrational? It's a never-ending, ugly decimal. What could you kind of compare that to?
A really crappy foundation.
Yeah, a really crappy foundation. It's kind of like building your house on gravel or sand, okay? You never want the denominator to be irrational. You don't want that. You don't want your denominator to be irrational, or else it's like the foundation of your house is being built on gravel as opposed to concrete. We want a nice, pretty, rational foundation for our house. So let's take a look at a couple examples here. Look at the first example, the square root of 4 over the square root of 2.
It's 1.
What is the square root of 4?
2.
It's 2. But what about the square root of 2?
It's ugly.
Yeah, it can't simplify. There's no dates to prom in there, and there's nothing I can really do about it. And the square root of 2, if you put it in your calculator, what do we know about the square root of 2? It's ugly. And if I ask my calculator to turn it into a fraction, it says no. So our house is currently built on gravel. Okay? The way that we can fix this is we can get it to cancel out. How can we get a square root to cancel out?
Multiply by
Multiply it by its...
reciprocal.
Or you can
No.
just square
Make
it.
it easier. Square it, right?
Yeah.
A square root squared cancels out. They're inverses of each other, Haley. Squaring it is also the same thing as multiplying it by itself, right? If I say x squared, that's really x times x. 2 squared is 2 times 2. Now you'll notice, what is the square root of 2 times the square root of 2 based on the warm-up we just did? It's the square root of
4.
4,
Which is 2.
and the square root of 4 is 2.
Okay.
So now our denominator is really pretty. It's a 2. It's a nice whole solid number.
Don't we have to do the bottom, we have to do the top?
Correct. The only catch is if you do it to the bottom of the fraction, you also have to do it to the top. So I also need to multiply the top by the square root of 2.
Which then it gets
So what is 2 times the square root of 2?
2 square root of 2.
Yeah, just 2 square root of 2. Kind of like 2 times x, right? We just call that 2x. One's a whole number, one's a never-ending decimal. I can't smash them together. You get a decimal. So we just keep them separate, okay? Now, that ultimately comes out to 2 square root of 2 over 2, right? But what happens when I have a whole number on the top that's the exact same thing as the whole number on the bottom?
They cancel out.
They cancel. What's 2 divided by 2?
1
So my answer is
square root of 2.
the square root of 2.
That's crazy.
Now, just like always, I've showed you before, you can actually check your answer. So if I put the square root of 4 divided by the square root of 2 into your calculator and get a decimal, it's going to tell you a decimal. But now, if you put your answer in the calculator, what should the decimal be? The same.
Well, didn't we figure that out? Well, no, because you plugged in the square root of 2, and if we would have just plugged in the beginning, we would have figured out that was the answer.
I'm not sure what you're saying there.
That would work.
Not smart, okay, guys?
Any questions on that? Denominator. Is there anything wrong with this 2 right here?
No.
No, the 2 is actually good. That's a whole number.
It's
Okay.
the 5.
The square root of 5 is the problem. So on this example, the only thing we need to multiply is the square root of 5 on the top and the bottom.
Why's it 2?
That's a whole number. That's a good foundation, right? 2 is rational. 2 is good to have. Square root of 5 is irrational. It's like gravel.